day and greetings to you. Welcome to our WorksheetCloud Grade 9 Natural Sciences lesson. If you have a question during the lesson, send an email with your question to grade9@worksheetcloud.com. I am so glad that you could join us today, and my name is Mrs. Ernston. I'm the WorksheetCloud Grade 9 Natural Sciences teacher. To those that have been with me for a long time, I know you're all ready and prepared for this lesson, and you have your books open and a pen or pencil to write with and some paper to jot down your notes. To those of you that have just joined us today, welcome. I'm delighted that you made the time to be here. I would like you to take notes as we work through the lesson. I'd like you to engage. I'd like you to pause the video where necessary, and I'd like you to leave the lesson with a copy of notes, so that when you do the worksheets or you interact or you study for a test or an assignment, you have something to study from. So I would like you to have a look at these pictures and try and see if there is any way that you can link them together. So let's go through them, and if anything comes to mind, jot it down. Here we have some charcoal, and it looks like it's all burning and all ready for a braai. Here we have a coal-powered station. Here we have a wind turbine. Here we have some dried apricots, and this could represent any dried fruit. And here we have some wine. And here we have a schematic representation of an oxygen molecule. So I'm going to give you a little bit of time to think about how all of these things are related. Okay, now keeping those pictures in mind, we're going to work through the lesson, and hopefully at the end of the lesson, or as we progress through the lesson, you will figure out how all of those pictures are interconnected. So we'll start with oxygen. Oxygen is all around us. It is in the air we breathe, and it is a very reactive element. When an element is reactive, it means that it will readily react with many other substances. And we saw evidence of the reactive nature of oxygen when we observed how it reacted with iron and magnesium to form metal oxides. And if you've missed out on those lessons, please go and have a look at our lessons. I think there are 3 or 4 of them about how metals react with oxygen. So if we revert back to the periodic table, in today's lesson, we're going to be looking at 3 elements: oxygen, carbon, and sulfur. So we represent oxygen by a capital O, carbon by a capital C, and sulfur with a capital S. When a substance reacts with oxygen, we say that it oxidizes, and this is called an oxidation reaction. And this substance can either be an element or it can be a compound. Now there's an interesting thing to remember about this term oxidation, because early chemists used the term oxidation for all reactions in which oxygen was a reactant. However, over time, the definition for oxidation has developed and is much broader, and you will cover this if you take science for grades 10, 11, and 12. So when a non-metal burns in oxygen, a non-metal oxide forms as a product. So the word equation is going to be the name of the non-metal plus oxygen reacts to form a non-metal oxide. So have you ever seen coal burning in air. Think of when you start the braai or you're making a fire. Have you ever actually watched what happens to those coals? So coal is a form of carbon that is used as fuel for many different purposes. It is one of the primary fossil fuels that humans use to generate electricity for powering our industries, or for activities, or for living purposes. So coal burning in air. The energy in coal comes from the energy stored in plants and other organisms that lived hundreds of millions of years ago. And over the millennia, the layers of the dead plants and other biological waste were covered with layers of water and soil. So the heat and the pressure from the top layers caused the plant remains to turn into this energy-rich coal, and the plant remains and animal remains you will commonly known to be fossils. So the energy released by burning coal is used to generate electrical energy in coal-powered stations, and that is how our electricity is generated in South Africa. So coal is a form of carbon, and when it burns an oxygen, we can represent the reaction with the following word equation. Carbon plus oxygen react to form carbon dioxide. So in the naming of this compound, if we just go over the rules quickly, you write the name of the non-metal first, which is carbon, and there's no changes. And then with oxygen, you change it to oxide. And because when carbon reacts with oxygen, we get carbon dioxide. If we have a look at the picture reaction below, carbon dioxide, the reason why we don't say carbon oxide is because there's 2 atoms of oxygen in this compound. So because there are 2 atoms of oxygen, we use the prefix di. So if you've got to draw a picture for this reaction in the space below in your notes, you are going to draw a ball for carbon, and it really doesn't matter what size you use or what the color is. And then you're going to use a different colored circle for oxygen. And the reason why oxygen exists as 2 is because it is diatomic molecule, and the compound is CO2. So there's the carbon, and there are the 2 oxygen atoms. So we represent number of atoms in the subscripts. And if we have a look at this equation, it is in fact balanced. So here we have 2 oxygen atoms on the reactants, 2 oxygen atoms in the products, 1 carbon in the reactant, and 1 carbon in the product. Coal is a non-renewable energy source. And along with that, it also causes a lot of pollution and many other environmental problems. So scientists and engineers need to look for alternative fuels and energy sources to eventually replace coal as an energy source. Can you think of names of some of the alternative renewable energy sources? I have put some pictures below to help you. So here we have a wind turbine, so we can have wind generation. Here we have solar panels, so we can have solar power. Here we have water, so we can create hydroelectric power. And I wonder how many of you were able to figure out what's going on here. This is one of the renewable energy sources that is often not spoken about, and that is geothermal energy source. So which non-metal do you think reacts with oxygen to form sulfur dioxide? Correct, it's sulfur. And we can represent the reaction with the following word equation. Sulfur, which is our non-metal, plus oxygen reacts, we show the reaction with an arrow to make the compound sulfur dioxide. So we keep the naming of the non-metal as is, and then for this we leave a space. And for the second part of the compound name, we take oxygen and we add "ide" to the end. So we don't call the compound sulfur oxygen. It's sulfur oxide, but the reason why we add the prefix "di" is because in a molecule of sulfur dioxide, there are 2 oxygen atoms. So in your notes, please draw a picture equation for the reaction shown in the space below. So here we have sulfur plus oxygen. Remember, in its natural state, it's diatomic. Reacts to give us sulfur, and then di, 1, 2. Oxide is the oxygen. So which non-metal do you think reacts with oxygen to form sulfur dioxide? Here we have a word equation. And just to remind you that when we have a chemical reaction equation, the elements that are written to the left of the arrow, so the arrow represents the chemical equation. The elements that are written to the left are known as the reactants. The elements or substances that are written to the right are known as the products. And if we have to take this word equation and convert it into a chemical equation, we'll go to the periodic table and see sulfur, we use the letter capital S. Oxygen, we use the letter capital O, but it's diatomic, so we say O2. Reacts, there's our arrow to show the chemical reaction. Sulfur dioxide, which is written as SO2. And here I have an experiment for us to watch about the burning of sulfur and oxygen.
So here we take a look at burning sulfur and pure oxygen. This is what sulfur looks like. Sulfur is a bright yellow powder. And in this gas jar here, I have oxygen. Oxygen is a colorless, clear gas. What I'm going to do is take some sulfur in on a combustion spoon here. You see what a combustion spoon looks like. This thing here acts as a shield, shielding me from any sparks that might fly up. And at the same time, once I put this combustion spoon into the gas jar, here's an empty gas jar, once I put it into the gas jar like so, it seals the contents inside. So, remember here I've got a gas jar of pure oxygen. The air is 1/5 oxygen, 4/5 nitrogen. Anything that burns in air will always burn even better in pure oxygen. So what I'm going to do is to take a little bit of this yellow powder here on the combustion spoon, not too much. I'm about to reduce a very poisonous gas, sulfur dioxide, formula SO2. Even small amounts of this gas that I'm about to reduce can bring on attacks of asthma, usually a few hours after exposure to the gas. Now here I've got my Bunsen flame. I'm going to put it to a blue flame, non-luminous flame. And I'm going to melt sulfur. So let's see if we can pick this up in detail. The sulfur begins to melt right away, and you can see on the surface it's already beginning to turn a ruby red color. So I continue to melt the sulfur. Doesn't take much heat. There's it all melted. And that yellow powder is turned into red colored liquid. I now ignite the vapor. It's now beginning to vaporize. I ignite the vapor and I lower it into the gas jar of pure oxygen. And there you see a beautiful blue flame. Some UI indicator paper there. Yeah. So it's producing a choking gas, sulfur dioxide. So I'm going to put this into the fume cupboard right away.
So sulfur burns in oxygen to form sulfur dioxide, and a reminder that sulfur dioxide is a very poisonous gas, so it is quite probable that this experiment is only conducted if you have a fume cupboard or something like that at school, because this gas is really very poisonous. So here we have what sulfur powder looks like. Here we have a collecting jar that is filled with gas. We take some of that sulfur powder and we put it into a deflagrating spoon and we heat it over a Bunsen burner. And that powder is going to melt and turn into like a reddy orange color. And then you're going to, once it is lit and the vapor has started to burn, you're going to take it and you're going to put it into our jar of oxygen. And when we do that, we get a brilliant blue flame. It really is important that you record the process of what happens in this reaction, because it is quite possible that you will be expected to remember these things. That sulfur is a yellow powder in its natural elemental form, that oxygen is a colorless gas, and that when we burn sulfur in a flame, it goes to a reddy brown color, but when sulfur is put directly into oxygen, it burns with a brilliant blue flame. So hopefully you got that information down now. Now what is very interesting is how do we now link these things together from the beginning of the lesson? How do we link apricots or dried fruit, those yummy dried guava rolls? How do we link that with wine and sulfur dioxide? Because they were telling us how sulfur dioxide is a poisonous gas. So I wonder how these three are all related. Should we go and have a look? So sulfur dioxide is sometimes used as a preservative for dried fruits, such as dried peaches or apricots or guava rolls. Now what is important is sulfur dioxide is a preservative, and sometimes it can be used in fruit juices and things like that. And I know particularly for some children that are asthmatic, they respond really badly if they eat anything that has been preserved with sulfur dioxide. So if you do have these allergies, it is very important that you do check the labeling of the product and you see whether or not the product has been preserved using sulfur dioxide. Now, sulfur dioxide is in fact toxic, but it is used in very, very small quantities in the process of preservation. But if you are allergic in any way to sulfur dioxide or you are prone to have asthma, it is important for you to stay away from any food products or drink products that have got it. So please check your labels carefully. Now, in very small quantities, sulfur dioxide does not permanently harm a particularly large organism like a human being, but bacteria cannot survive when it is present. And there are quite a few antibiotics that are used that are sulfur-based. And often when you go to the doctor, they will ask you if you've had any reaction or if you are allergic to any antibiotics, because we get two types of antibiotics. Some are penicillin-based and some are sulfur-based, and it's very important that if you are allergic in any way to sulfur or sulfur dioxide that you get given the right antibiotics. Otherwise, you can have a bad reaction. And then sulfur dioxide is also an important preservative in many of our South African wines. So here is a recap of everything that we have covered this lesson. We've had a look at the general reaction of nonmetals with oxygen and how when nonmetals react with oxygen, we form a metal oxide. We also learned that a nonmetal can be burnt in oxygen, and if we do, the chemical reaction equation can be represented by a nonmetal plus an oxygen react to give us a nonmetal oxide. Then we went through the reaction of carbon and oxygen. So when a nonmetal carbon is burnt in oxygen, carbon dioxide is produced. The word equation for that is carbon plus oxygen reacts to give us carbon dioxide. The chemical equation is C plus O2 gives us CO2. And just a link to some of our previous lessons, this equation is already balanced. And then if we have a look at the reaction of sulfur with oxygen, sulfur reacts with oxygen to form sulfur dioxide. The word equation is sulfur plus oxygen reacts to form sulfur dioxide. And the chemical equation is S plus O2 gives us SO2. And again, this reaction is already balanced. So what have you learned in today's lesson? I would like you to try our little activity 3-2-1. So that is write down 3 things that you discovered in this lesson, 2 interesting or facts or details, and 1 question you may still have. And if you are unable to find the answer for that question, you're welcome to email your question to grade9@worksheetcloud.com. And I would like to send my huge thanks and appreciation to WorksheetCloud for bringing you this lesson today. But more importantly, this lesson couldn't happen if there weren't some awesome grade 9s out there ready to watch this lesson. So thank you, grade 9s, for being proactive, for being in control of your learning, and for taking the time and effort to be with me today to learn something new. So thanks for joining the lesson, grade 9s, and I look forward to seeing you in our future lessons. Bye.